Look at the sheer physical footprint of modern artificial intelligence. We are building digital structures so vast they exceed our ability to map them by hand. For the better part of a year, the absolute ceiling for open-weight AI models hovered just below the 1.5 trillion parameter mark. But today, that limit has been completely shattered.
Welcome to the Bitstock. Today, we are breaking down a monumental milestone in technology, the release of Kimi K3. This is the world's very first open 3 trillion class AI model. It packs a staggering 2.8 trillion parameters and actively holds 1 million tokens of context in its memory at any given moment. It isn't just a chatbot waiting for a prompt. It is a 24/7 autonomous worker, purpose-built for long-horizon coding, deep science, and complex reasoning. When you scale an AI up to nearly 3 trillion parameters, the biggest headache is getting all those parameters to fire without bankrupting your compute power. Kimi K3 solves this with extreme sparsity. It uses a highly specialized mixture of experts architecture. Think of it like a massive corporation with 896 highly specialized employees. When you give it a task, it doesn't wake up the whole office. A routing mechanism activates exactly 16 experts needed for that specific job, leaving the rest dormant. Combined with their new Delta attention mechanics, this gives K3 a massive 2.5 times improvement in overall scaling efficiency. It doesn't just know more, it thinks better, and it can afford to think independently for days. So what happens when you leave K3 to its own devices as an autonomous software engineer? Engineers put K3 in an isolated sandbox and told it to optimize GPU kernels. For 15 hours straight, with zero human oversight, it profiled, rewrote, and benchmarked its own code. It designed a novel algorithm that cut processing time from 284 milliseconds down to a blistering 114 milliseconds. But it didn't stop there. K3 was then instructed to build an entire GPU programming system from scratch. It successfully developed Mini Triton, a complete end-to-end GPU compiler. It generated the front-end language, the intermediate logic layer, and raw hardware instructions. It is literally writing the foundational software that allows other AI to even exist.
Now, most models can take a static image and give you some code, but K3 has what the team calls true vision in the loop. It natively parses visual data. To prove this, K3 autonomously built a fully procedural, browser-based 3D open-world game. It didn't just write a script, it dynamically iterated between writing the code and actively analyzing live screenshots of what it just built. It instantly saw its own output, caught visual bugs, and art-directed an entire playable world, complete with weather systems and 3D models completely on its own. Let's transition from virtual worlds to the absolute extremes of physical reality. In a single 48-hour autonomous run, Kimi K3 took on the role of a physical chip designer. Using open-source tools, it laid out a microchip right down to the microscopic level. Within a tiny 4 square millimeter footprint, it packed nearly 1.5 million standard cells. We now have an open-source AI autonomously designing physical microchips to run other AI models. It's a breathtaking recursive loop of intelligence. And in the realm of hard science, the team tasked K3 with computational astrophysics, reproducing universal relations for compact stars. K3 cross-validated 20 dense scientific papers, identified actual math errors in peer-reviewed formulas, and wrote 3,000 lines of Python, a workflow that takes an experienced human researcher up to 2 weeks of dedicated focus. K3 completed autonomously in just 2 hours. Zooming out to the bigger picture, a chip built by a model for a model signifies a massive shift. We are no longer dealing with a static assistant waiting for you to hit enter. K3 is a continuous, long-horizon agent capable of maintaining logical consistency across a million tokens. The only question left is, what are you going to build with it?